Welcome everyone, and we're going to look at an extension of what we started with last time. Last time we looked at sequences and series, and now we're going to focus on two specific subtypes of sequences and series, arithmetic and geometric sequences and series specifically. So the first one we're going to look at is obviously arithmetic sequences. And so as a way to start that, I want you to think about this example problem. So imagine you're in the future a ways, coronavirus is done and you've completed college and you're starting a dream job and it pays $40,000 and maybe you're happy about that, maybe you're not. Nevertheless, it is what it is. And so each year though, on top of that 40,000, you get an increase of $3,000 each year. Okay, and so let's assume that you don't receive any other pay increases or bonuses, et cetera, et cetera. And the question is, what is your salary annually when you retire 45 years in the future in that same position? And so, okay, the question is, how do we represent this? Well, if we kind of make a table, you can imagine like here N, and here's your salary. Okay, so in year one, right, you make 40K. Okay, and I'm just going to abbreviate it like this. And then, well, then year two, you know that you get that cost of living increase and you're now at 43K. And maybe you're happy about that, maybe you're not. Okay, then year three, you'd be at 46. And then you just keep going. And then what is it going to be at year 45? And so certainly you could, iterate through and do this manually, or maybe you can leverage the power of mathematics because you notice that each time you go up by $3,000. Okay, so then if you think about it, you could say, well, year 45, you would have 40,000, right? And then how many times would you add 3,000? Well, that would be adding 3,000 45 times, or 44 times rather. Okay, so then, boom, you can get your answer of $172,000 annually. And I look at that and I'm like, huh, that's pretty nice. Okay, well, at least I think so, because 40,000 was actually pretty close to what I started at UMR, so a little bit higher, but pretty much on the same spot. And I have not received a $3,000 pay increase each year, so take that as you will. But nevertheless, that would be a nice salary to have after 45 years of service. But nevertheless, the idea here is if we look at the sequence of salaries, that forms what we call an arithmetic sequence, because what we're doing is we're taking that initial amount, A1, and then we're adding some amount to that that's the same from year to year. Okay, and so we just have to add it some number of times to get the next value, or the desired value in the sequence. Okay, this common amount that we add from year to year, we call that the common difference. And mathematically, what we end up doing to find this common difference, we take the term after minus the term before. Okay, so in other words, you can see what I did. I did that here. I represented the addition from one term to the next as 3,000, but I could have done it a different way. I could have said D is equal to 43,000. I'm just going to do 43K minus 40K, and then that gives me my common difference of 3,000 or 3K. All right, so that's how we can get our common difference. And then once we have that common difference, we can find any term we wish in the sequence by simply taking the first value of that, in my example was 40,000, and then adding some number of the differences to that, and it's typically n minus 1, so the number you'd add it n minus 1 times, and boom, there it is. Okay. Now, the other way to generate this an value, or the entire arithmetic sequence, is through recursion. And so to do recursion, it's simply, if you think through that table, it's take the previous term, add the common difference of 3,000, take the previous term, add 3,000, always add 3,000 to get the next table, or next value in the table. Okay, and so I have a bonus question here. What does it look like graphically? Well, if we were to plot this, right? Okay, so here's year one, year two, and I'm just using my salary example. Okay, and so I'm just going to put, here's 40,000 and here's 43, 46. what we should get is something that looks very familiar to us. It would be a line of dots. Okay, we can't connect it because these are discrete values. We don't have a salary at year 1.5, for instance. So we just get this sequence of dots that form a line. Okay, so that's kind of interesting. And mathematically that makes sense because this is your intercept, and then this is your x value, your independent variable, and here is your slope. Okay, so d is your slope. All right, nevertheless, some examples here. Okay, and all we need to do is determine if this, at least in skill practice 1, if we have an arithmetic sequence. And so what we need to do is find the common difference. And so I look between consecutive terms. Between consecutive terms here, I'm subtracting 7, subtracting 7, subtracting 7, subtracting 7. So is that change between successive terms always constant? Yes. And so if I look for D, I can compute that as, say, A3 minus A2, which this is going to be minus 2 minus 5, right? Third term minus second term. And I get minus 7. And you can do this with any successive pair of terms and you'll get the same thing. All right, and now here, if I look between here, if I do this, let's see, the common difference here is 3, and then the difference here is 5. Okay, immediately I can stop, because as soon as I look at the difference and that is not constant, then it's going to be not arithmetic. So I'm going to say this one is no, not arithmetic. And I should actually say this one is yes, it is. Okay. All right, for the next skill practice, okay, it says write the first 4 terms of an arithmetic sequence with the first term of 8. So, okay, I'm just going to write this. Sometimes it just helps me to write the sequence out. So first term 8 and common difference of minus 3. So that means between successive terms, I'm doing 8 plus negative 3. So this is really 8 and then 5. And then this would be 8 plus negative 3 times 2. Okay, so then that would be just positive 2. And then I would do 8 plus negative 3 times 3, or minus 1. And you can start to see the pattern. Okay, and, oh, I actually did the first part of the first question here, so we're good. In part B, okay, a recursive formula. So this one is saying to get the next term, I take the current term and add negative 3 to it. Okay. Now, also with the recursive formula, this is not the only thing you need to do. You need to state the starting point, which for us is just 8. So I have to give the starting value as well as the recursion formula. Okay. And so just a side note, this part of the recursive formula for an arithmetic sequence stays the same. The only thing that changes is this, and this is your value of D. Okay. So there we go. Recursive formula need 2 parts. Our last example for this video, and then we're going to go on and have more, is this homeowner example. So do they follow arithmetic progression? Okay, so another way of asking that same thing is there a common difference? Okay, and so if we look closely, I notice from here to here, or from year 1 to year 2, that goes up what, 540? Okay, and if I look from year 2 to year 3, that is also 540. And from year 3 to year 4, that is also 540. So I'll say yes. Okay, and I know it is arithmetic because I can state the common difference. D is 540. Okay, expression for the nth term. Okay, so then this is saying to get the nth term, or the amount at year n, it would be this base price of 102.60 plus some number of times we have to add this 540, or 5.4. Okay, so this is the nth term. We could also describe this using the arithmetic sequence as well, or a recursive form as well. Lastly, predict the average monthly bill for year 6 if this trend continues. Okay, I'm going to do that down here. So if I want to find A6, that means, okay, N is 6. So all I'm going to do is say this is that 102.60, oops, 102.6, not 110.6, okay, 102.6 plus 6 minus 1 times 5.4. Okay, and then we grab a calculator and punch this in. You're welcome to double check my answer, but I got 129.6, and so what I'm going to just do is translate this into context. I'm going to say on year 6 we predict the average monthly electric bill to be $129.60. Okay, there we go. All right, so arithmetic sequences always look for that common difference, and then remember that if we're doing a recursive formula, we have just this an is equal to an minus 1 plus d, or you can, if you're looking for a non-recursive formula, to use the first term plus some number times the common difference.